I want to share with you guys the things to think about as you're trying to discuss the difference between the derivative of a function and the parent function. Each of these graphs, 1, 2, 3, 4, 5, those are all meant to be derivatives of a function, and you're expected to write the antiderivative or the parent function where the derivative of that parent function looks like this. So in order to think about or get in the proper headspace to answer these questions, you need to be thinking about not what the height of this function is, but actually what does the positive or negative nature of this function tell you about what the parent function actually looks like. Some other things that we know, that in the parent function, f of 0 equals 0. So I can go ahead and just put a dot right there because I know that my line is going to pass through the origin. So to the left side, I'm going to start with what I think is the easiest. To the left side, this function has the derivative has the line below the x-axis, and when you have the line below the x-axis, that tells us that the parent function is decreasing through that value. In fact, the lower this line goes, the steeper the parent function actually is for those corresponding x values. So really close to f of 0, the line isn't all that, the derivative isn't really all that low. So that means that the parent function isn't really all that steep. You can kind of imagine it being like a smoothie, kind of like low curve. But the further that this derivative goes away from the x-axis, the deeper it goes, the more negative it goes. That tells us that as we move along the x-axis in this direction, the parent function gets steeper and steeper and steeper by these values. So it'll turn into looking like a parabola kind of function where it just gets really steep, and I know it went off the window, but the parent function gets really, really steep the further to the left we go. Then we get to this part right here where there is, on the derivative, there's this lowest part of the derivative. So there's a section between 0 and 0 and 3 that's the steepest. It's really at 2. Once again, as the derivative moves away from the x-axis, it tells us that the parent function, the original function, is steeper or getting more and more steep until it reaches this value, x equals 2, where the parent function is the steepest it'll possibly get before coming back to a value of 0. We're still negative. In the interval from 0 to 3, the derivative is still negative. That tells us that the parent function is still a decreasing function between 0 and 3. So as I draw my antiderivative, my parent function, my original function, it's going to look something like this. Right? It gets to its steepest value at 2, and then it levels off rather quickly from 2 to 3 until it approaches, let's see, this is a height of 0, so the parent function has to have a slope, a flatness to it, because the derivative crosses the x-axis. And then, because this is positive, the graph is above the x-axis, the derivative is above the x-axis, that means the parent function is going to start rising sharply from that point on. Now, I might not be 100% accurate, and I'm not concerned with that, but in terms of general shape, the general shape of the parent function looks like this because it's decreasing, 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 flat, decreasing, 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 flat, and then positive again. And it's 100% due to the fact that the derivative is negative, 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 0, negative, 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 lowest negative value, so steepest of the parent function, and then back up to negative, 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 0, and then positive, 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 positive. I could also make a relationship right here too. This is approximately an x cubed function. There's other things going on. That means it's not straight up x cubed, but it's definitely a third degree polynomial. The parent function would be the antiderivative of this third degree polynomial, and functions that have derivatives who are x cubed are functions like x to the fourth. And even though, 4x to the third power. It doesn't matter what the coefficient is. This function looks like this, like a W, or like, some sort of other weird shape. Its derivative will look like a cubic, or some sort of, you know, uh, odd function. So I could also establish a connection between the derivative, highlighted in yellow, and the parent function, because the parent function looks like an x to the fourth function, while the derivative looks like an x to the third function. So here's the picture of the derivative, where it's negative and 0, and then positive. And here's a picture of the parent function, where it's decreasing, decreasing, and then flat, flat right here too, and then increasing after the value x is greater than 3.